So this is lab 3, the USART initialization and echo. So if we come down here and type 3 characters X, Y, Z, and we hit enter, it will send them back, except that we connected at the wrong baud rate. So let's try that again, X, Y, Z, and it'll give those back. We can do ABC, and it works again. Okay, so this is lab 4, which is the pin change interrupt sending a signal to count bounce. So if we press it now, we're getting a lot of 1s, and there's a 3 or 4 in there. This is lab 5, the USART transmit interrupt handler. And what this is going to do is we're going to try to transmit a message, hello world. It will trigger a ISR that will actually transmit the data by stepping through the buffer, and it will print hello world every second. So if we connect down here, we get hello world. This is lab 6, the receive interrupt handler with USART, and looking at the code, we have code to receive the data, and if we come here, we can connect to the board, say hello world, and we're going to get back. So this is the beginning of lab 10, working with timers. Due to some compilation stuff, this is going to be coming in little bits of video, but this is just a base state with an LED so that you can see it on. So this is part A, which is using the leapfrogging technique, going up to the OCR 1A value and then adding on to that with an ISR and continuing. This is part B of the lab, which is another ISR based timer. And finally, this is part C, which uses internal interrupts to handle the pin change. Alright, so this is lab 14, the multi-threading executive. I'm actually going to unplug this red LED. This should be flashing at 4 Hz, but it is making it hard to see the rest of the board. So this is with a potentiometer. We can alter the brightness of the blue LED. For the diagram, there is a... Here it is. Here we go. So for the board, the red wire is plugged into pin 53 that controls the blue light. The black wire controls the red light for 4 Hz and is plugged into pin 52. The data from the potentiometer goes into analog 0, and grounds and positives are connected.
Unplug.
And I also forgot that one of the threads is a terminal input, so if we connect, we'll start getting voltages there, which
Are hard to see, but are correct.
by twisting the potentiometer they go up and down. So, and that is also lab 13, is the analog to digital converter.